Good evening, everyone. Today in this class, I would like to explain about the IUPAC nomenclature. Okay, so what is an IUPAC? Let us see. Generally, the organic chemistry having a millions of compounds, right? It is deals with the millions of compounds. So to identify what is the proper name of that compound, so there is a systematic procedure is there. So in order to give or identify the specific name, an IUPAC is an organization. It develops some methods, some systematic procedures to identify the specific compound. So IUPAC means International Union of Pure and Applied Chemistry, right? So it is the organization which deals with millions of compounds, and it gives some systematic methods to identify the compound, and it is universal, it is acceptable in everywhere. So now there are some rules are there to name the compound. So many students thought that Iupac nomenclature it is somewhat a lengthy topic and it is somewhat difficult to understand, but it is quite simple when you concentrate perfectly. So let me make this compound very easy to all of you regarding your examination point of view. So let us begin the class. So generally every compound containing so many what you call so many different names, but in IUPAC name it is the everywhere it is the acceptable method. So let me introduce one compound. So CH3, CH2, CHCl and CH2, CH2, COOH. So this is one compound. So how many carbons are there here? 1, 2, 3, 4, 5. So let me write one here. So OH. So this is the first carbon, second one, third one, fourth one, fifth one. I will explain all the topics very clearly, so you need not worry about it. So let me introduce the one compound here. So it is containing 5 carbons. So here at the third carbon it is containing the chlorine substituent. So now what is the name of the compound? So here it is containing OH group, alcohol group. So it is containing 5 carbons means it is called pent, and it is containing chlorine substituent at third carbon. So it is named it as trichloro-pentane because all are single bonds here, and it is containing alcoholic group at first carbon. So 1 ol. So 3-chloropentane 1 ol. So this is the IUPAC name of that given compound. So what is 3-chloropentane 1 ol? How did you write this name? Which means there are some rules. So let me explain the rules one by one. So here generally to write the IUPAC name there are some properties. First is every compound should contain one root word. Is it okay? So this is the main root word. So before the root word it contains one prefix and suffix. So I think what is the prefix and what is the suffix? I will explain all the topics one by one, stepwise. Okay. So here first point is that every compound must contain one root word. Root word means here the compound containing how many carbons. Is it okay? If the compound is containing 9 carbons, if the compound may contain 8 carbons, whatever it may be, the root word indicates number of carbon atoms. in that molecule, given compound, given molecule. Is it okay? And what is the suffix? And what is the prefix? So if suppose, let me explain clearly. If there is one carbon in that molecule, then we name it as meth. If there are two carbons, then we call it as eth. If there are three carbons, that is called prop. If there are four carbons, that is called but. If there are five carbons, that is called pent. So if there are six carbons, then it is called hex. 7 carbons, hept. 8 carbons, oct. 9 carbons, non. 10 carbons means dec. So there are number of infinite carbons are there, but we are concentrating up to 10 carbons. If the given molecule is containing one carbon, then we call it as meth. If 2 carbons, eth. 3 carbons, prop, but, pent, hex, hept, oct, non, dec, like that. So the root word indicates, it is very important point, it is better to write down. So root word indicates the number of carbon atoms. So if it is if the given compound is containing only one carbon, single carbon, then we call it as meth. If it is containing 10 carbons, then we call it as dec, like that. So this is the major part. So now let me explain what is prefix and what is suffix. Now, what is the prefix? Generally, the prefix is containing mainly two parts, primary prefix and secondary prefix. Is it okay? So, what indicates the primary prefix and what indicates the secondary prefix? So, primary prefix means if the compound is giving a cyclic compound, then we have to mention cyclo in that name. If it is an open compound, then you need not write anything. Non-cyclic, you need not write nothing. You have to write nothing there. See, if the compound is giving cyclic compound, you have to write it as cyclo. If it is an open compound, open chain compound, you need not to write anything. Or if the given compound is bicyclic compound, then you have to write it as bicyclo. So you have to note down all the points here, because these are the very key points, important points. Or if the given compound is spiral compound, then you have to write down it spiro. Is it clear? If the given compound is cyclic, then you have to write cyclo word there in the name. If the given compound is bicyclic, then you have to write bicyclo. If the given compound is spiral, then you have to write spiro. Is it okay? If the given compound is contain nothing, means it is not a cyclic compound, it is not a bicyclic, or it is not a spiral, then you need not to write any word there. Is it okay? And here in between the root word, before the root word, you have to mention the primary prefix. Is it okay? If it is a given compound, then you have to write cyclo. Before the root word, you have to mention that word. Is it okay? Now, let us see what about the secondary prefix. So now, the secondary prefix. So, secondary prefix indicates the substituents, nothing but. So, the given compound may contain substituents. Then you have to mention the substituents at the secondary prefix. See here, the order is, first of all, you have to write the secondary prefix. after that primary prefix, then root word. So this is the order. Then after primary suffix, then after secondary suffix. So I will discuss about what is primary suffix and secondary suffix, all those things. So I am telling here, this is the order. And now what are the substituents? See, if some halo compounds may given like substituents, if chlorine is given like that, if chlorine is given in the previous example, there is a chloro compound, chlorine is given. So if chlorine is given as a substituent, then you have to write it as chloro, like this. If bromine is given, then you have to write it as bromo. If iodine is given, you have to mention it as ido. If NO2 is given, nitro, you have to write it down as nitro. Is it okay? If OH is given, then you have to write it as hydroxo. See here, the OH may be given as prefix as well as suffix. So if it is given at the substituent, given as a substituent, then you have to call it as hydroxo because it is treated as prefix here. If it is given at the functional group, then you have to write it as ol. If suppose CHO is given, then you have to name it as carbaldehyde. If R is given, then you have to write it as alkyl. OR is given, then you have to write it as alkoxy. For example, RCH3 is given. CH3 means here methyl, so you have to mention it as methyl. If C2H5 is given, then you have to mention it as ethyl. So if cyano is given, you have to mention it as cyano. Like this, the secondary prefix indicates the substituents. Substituent means if they may be alkyls, alkoxy, halides, chlorine, bromine, iodine, nitrogen, cyano. So all the compounds may be given as a substituent, then you have to mention it as secondary prefix. So is it clear? So primary prefix indicates whether the compound may contain cyclic or not, or bicyclic or not, like this. And the secondary prefix tells about the substituents. It indicates the substituent. Now let us see what about the suffix. We have to explain clearly what is the root word. So root word means it tells the compound containing number of carbon atoms. Is it okay? And we have to discuss about the prefix also. Prefix may contain primary and secondary. Here the primary prefix indicates whether the compound may contain cyclic or not, and whereas the secondary prefix indicates the substituents. Now let me explain about the suffix. So now let us explain about suffix. Suffix generally it is also two types. So primary suffix and secondary suffix. So what indicates the primary suffix? So whether the given compound may be saturated or unsaturated. So the primary suffix indicates whether the given compound is saturated or unsaturated. If it is saturated, then we contain single bond, which means it is alkane. Then we call it as alkane. If it is unsaturated, means it may contain double bond or triple bond. Unsaturation means double bond or triple bond. So if it is containing double bond, then we have to call it as alkene. And if it is triple bond, then we have to call it as alkyne. So the primary suffix indicates whether the compound is alkane or alkene or alkyne. Is it okay? If it is saturated or if it is containing single bond, means then we have to call it as alkane, and we have to write as ane. If it is a single bond, then we have to write it as ane at the primary suffix. If it is double bond, then we have to write it as ene. If it is triple bond, then we have to write it as ine. So this is all about the primary suffix. So primary suffix simply explains whether the compound is single bond or double bond or triple bond. So this saturation or unsaturation concept is explained by primary suffix. So if it is a single bond, then we have to name it as ane. If it is a double bond, then ene. If it is a triple bond, ine. So ine means alkyne, alkene, alkane. So this is what about the primary suffix. So now let us see what is the secondary suffix. So the secondary suffix generally indicates the functional groups. So generally what are the functional groups means there are a number of compounds are act as functional groups. If suppose halides alcohols may present OH group is present, then you have to write as ol. In the earlier example we have to write there pentanol, which means the functional group is here alcohol. That's why we are writing ol. If aldehyde is there, so CHO. Aldehyde means CHO. So we have to name it as al. See, if alcohol is there, OH group is there, then we have to consider it as ol. If aldehyde is there, then we have to write it as al. For example, ketone is there. Ketone means C double bond O. Then we have to write it as one. In the same way, carboxylic acid is there, COOH group. So this is called carboxylic acid. Then we have to name it as oic acid. Is it okay? In the same way, esters are there, COOR group is present there. Then we have to name it as O8. So amines are there, for example NH2 is there, amine, we have to name it as amine. So nitro compounds will there, so then we have to write it as nitro. So like this, the secondary suffix indicates the functional groups. If alcohol is present, then we have to name it as ol. Aldehyde is there, al. Ketone is there, on. Carboxylic acid is there, oic acid, like that. So not only these functional groups, there are so many functional groups are there. While doing examples, we have to know some more concepts. Okay. Now let us start how to write the names for some compounds. So let us start one example. Let us start. So here one compound is there, CH3, CHCl, CH2, CH2, OH. So what is the name of that compound? So there are 1, 2, 3, 4 carbon atoms are there. So the root word is here but, because here 4 carbon atoms are there. So that is why here the root word is 4, but. And here there is no cyclic compound is there. So that is why we need not to write the primary prefix. And we have to think about the secondary prefix. So here the secondary prefix chloro is there. So that's why if chloro substituent is there, we have to write it as chloro. And one more point here, the chlorine is present as a substituent at the third carbon atom. So then we have to write it as 3-chloro because it is present at the third carbon. So that's why we have to mention the number also. And but is a root word. Then we have to consider as we have to think about the suffix. So primary suffix here, all are single bonds. So that is why we have to write it as ane. So this is the primary suffix. And let us see the secondary suffix. Here functional group is also given, alcohol. So alcohol is coming, then we have to name it as all. So 3-chloro-butane, 1-all. So this is the exact name, correct name for this compound. Now here my question is why I am numbering the compound from here to there like this. Why I didn't giving the number from 1 2 3 4 like this? Is there any necessity to giving the number to the compounds? Yes. So there are lot of rules, number of rules are there while giving the names of IUPAC of that compounds. We have to follow some rules. So now let us see what are the rules. Let me explain one by one clearly. So here some rules are there. So what is the first rule? Let us see. So there is one compound. So the rule number 1 is, this is the first rule. Here one compound is given. So here the number of compounds are 1 2 3 4 5 6 7 8 9. So here the total number of 9 carbon atoms are there. So it is obviously non. So this is the root word. Now here one more point, all are single bonds only, which means it is alkane. So that's why no doubtedly I can write it as non-N. Now there is the no suffix is there. Is it okay? There is the no suffix, no functional group is there in the given compound. So you need not write the functional group. You need not mention the suffix. And here there are two substituents are there. What are the substituents here? These two are alkyl groups. So at the second carbon there is a methyl group is there, and at the 6th carbon there is a ethyl group is there. So obviously the name is, so these two are considered as secondary prefix, because there is a no primary prefix. Then we have to write down the primary prefix. So first of all we have to write 2-methyl, 6-ethyl, non-N. So this is the name of the given compound. But here I have a doubt. What is the doubt? So why I am giving the number from like this, from left to right only? Is it the correct way of giving the number? So why didn't I give the number from like this? So this is 1 2 3 4 5 6 7 8 9. So this is also possibility is there from right to left. But here there is a rule is there. What is the rule? Let me write. So when the molecule is given, when the compound is given, then we have to, the numbering is done in such a way that the branched carbon atoms get the lowest possible number. So this is the rule number 1. Is it okay? So when the branched, so here this is the branched carbon. Branched means substituent here. So this is also substituents. When these substituents are given, the substituents may get the lowest possible number. See here, if suppose whether I am giving the number from left to right, there are two substituents. The first one is at the second carbon atom, and the second substituent is at the 6th carbon atom. That is where the numbers are 2, 6. If suppose I am giving number from right to left, what are the numbers of the substituents? So at the 4th carbon atom and at the 8th carbon atom. So the numbers may be 4 and 6. So that is why here from left to right is the correct method in this case, because the rule is that the number is giving in that way that the branched carbon atoms get the lowest possible number. When the number is giving in that way that we have to consider the branched atoms, branched carbons or the substituents get the lowest possible number. So that's why here 2, 6 are the correct order, not the 4 and 8. So this is the rule number 1. You have to remember this rule, okay? So now let us see the rule number 2. Here the same compound is given. So here in the first case the number is giving in this way. In the second case the numbering is giving in this way. So which one is correct? So while choosing the branched chain, so there is a rule, longest chain. See, so the longest chain is the molecule is identified. So here this is all, there is also a chain. So 1, 2, 3, 4, 5, 6. So this is also one chain like this. But here in this case, in this chain only 8 carbon atoms are there. So here in this case, this is the longest chain because it is containing 9 carbon atoms. Is it okay? This is the second rule. In the molecule, the longest chain carbon is identified as the longest molecule. So that is why here, so this is the correct way. So this is the second rule. Now, so here the third rule is that, so same, the given compound is this. So it is containing 9 carbons, so it is anion, and it is containing 2 substituents here. So at the second position methyl group is there, and at the sixth position ethyl group is there. So the name is obviously 2-methyl 6-ethyl nano. But this is the wrong. See why? Because there is a rule. What is that rule? This is the third rule. So it is better to write down all the rules carefully, students. So what is that rule? If different alkyl groups are present, so here one alkyl group is there methyl, and the second alkyl group is there ethyl. So here like this, if there are different alkyl groups are present, then they are listed in the alphabetical order. So this is very important. So we have to write it as an alphabetical order. So methyl M, ethyl E. So what is comes first? Obviously E comes first. So that's why its name is 6-ethyl and 2-methyl nonane. Because here the numbering is not changed here. Numbering is not changed here because the number is itself, it is containing at the 6th position ethyl and at the 2nd position methyl. But the alphabetical order is following here. So that is why 6-ethyl comes forward. 6-ethyl 2-methyl nano. So the rule number 3 is, if there are different alkyl groups are present, then they are listed in the alphabetical order. So this is what the third rule. Now, so what is the fourth rule? Let us see. Here the 2 compounds are given. So let me write the number of the given compounds. So here 1, 2, 3, 4, 5. Obviously 5 carbons are there, so obviously it is pent, and all are single bonds, so that is why pentane. And it is containing some substituent. Substituent means here suffix, prefix are there. So this is the methyl group, and at the 4th position it is containing 1 methyl group. So here at the 2nd position it containing 2 methyl groups, and at the 4th position it containing 1 methyl group. So how did you write the names of this prefix? Obviously we have to write 2, 2, 4 trimethyl, is it okay, pentane. See here 2, 2, 4 trimethyl. Why I am writing like this? Because if 2 or more identical substituent groups are present, see here 2 or more identical substituents are present, then the numbers are separated by commas like this. And the number of the identical substituents are not repeated, instead prefix, such as if the substituents are repeated, if the two substituents are there, then we have to name it as di. If 3 are there, then we have to name it as tri. If 4 are there, then we have to name it as tetra. If 5 is there, penta. If 6 is there, hexa, like this. If substituents are there, same number of substituent groups are present in many ways, many numbers, then we have to name it as di, tri, tetra, penta, hexa, like this. So here in this case I am writing the name here trimethyl. See here, this is trimethyl because here 1, 2, 3. 3 methyl groups are presenting here. That is why I am using the word trimethyl. And where the 3 methyl groups are present, the numbering is also important. At the second carbon atom, 2 methyl groups are present. That is why I am writing 2 comma 2. And at the fourth position, the third one is present. So that is why its name is 2 comma 2 comma 4 hyphen trimethyl pentane. You have to differentiate the numbers by giving commas, by putting commas there. So this is the third rule, very important. And like this, shall we write the name of this compound also? So this is also containing 1, 2, 3, 4, 5. So obviously it is also pentane because there are no double bond or triple bond, all are alkanes only. So that is why pentane. And it is also containing some functional groups, some substituents. So at the, this is CH3. At the second position and at the fourth position, 2 methyl groups are there. So how did you write the name? So here the 2 comma 4 dimethyl. I am using the word here dimethyl because here the 2 methyl groups are presenting here. That is why I am writing dimethyl. And that the positions 2 and 4 at the second carbon atom and fourth carbon atom. So that is why the number is 2 comma 4 hyphen dimethyl pentane. So this is all about the fourth rule. See, you have to remember very clearly, if 2 or more identical substituent groups are present in the single compound in many words, then you have to separate the numbers by giving commas. And if there are if same substituent groups are presenting in identical substituents are repeated, then we have to giving the number. If 2 is there, di, 3 is there, tri, 4 is there, tetra, penta, hexa, like this. So this is all about the fourth rule. So the fifth rule is that here the compound is given like this. So it is containing 8 carbons. So obviously it is octane because all are alkanes only. So obviously it is octane. And here the functional groups are given 2. The substituents are 2 given here. At the third position, ethyl group is present, and at the sixth position, methyl group is present. So what is its name? Obviously 3-ethyl comma 6-methyl octane. Is it okay? Why? Because when the 2 substituents are given like this, then we have to follow the alphabetical order. So by following the rule, the compound name is 3-ethyl 6-methyl octane. But here there is a rule that if the 2 substituents are found in the equivalent positions, the lower number is given to the one coming first in the alphabetical listing. Is it okay? Once again I am repeating. If the 2 substituents are found in the equivalent position, then the lower number is given to the one which coming first in the alphabetical order. So here actually the alphabetical order, ethyl comes first, then after methyl comes next. Ethyl comes first and it is giving the lowering number, and here methyl is coming next and it is giving the highest number. So this is the correct one. If suppose I am giving the number from right to left, 1, 2, 3, 4, 5, 6, 7, 8, then it is the wrong, because here while giving number from right to left, here at the sixth position ethyl will come, and at the third position methyl will come. Is it okay? So this is wrong, because at the alphabetical order ethyl comes first. The substituent group which comes first in the alphabetical order, it is giving the lowering number. It should be given to the lowering number. So that's why this way is the correct one. Is it okay? Once again I am repeating. If there are 2 substituents found in the equivalent position, then lower number is given to the one which coming first in the alphabetical order. So in this case here this number is given alphabetical order, so ethyl comes first, so 3 should be the correct one, and methyl comes next, so 6 should be the correct one. While I am giving the number from right to left like this, then it comes 6 ethyl 3 methyl, so this is obviously wrong because this is the highest number. So this is all about some rules while writing the IUPAC names. So this is not enough to name the all compounds. There are so many rules are there. So in this video just I would explain what is an IUPAC and how to write the names and what are the rules, some rules. In the next video we will discuss some more examples with applying the these rules. Is it okay? And let us see some more examples in the next class. Okay, thank you all of you.